How's it going, new geometry class? Today we're going to be looking at composition of reflections. This is 9.6, the last section of chapter 9 that we're going to do as a video lecture. Okay, so think about what's composition mean. Composition means we're going to put together two different reflections. And when you have more than, or if you have two reflections, you're going to learn that it's not actually going to be a reflection anymore. Let's cut right to the chase. A composition of reflections across parallel lines is a translation. You don't believe me? Look at this. You flip it again. My orientation is back to where it was to begin, and all I've done is move it. And something to think about if you want to mark up the picture that you're drawing. This line's going to be perpendicular to both these. Keep that in mind. Reflect, reflection. That line's going to be perpendicular in any reflection. So, okay. And a composition of reflections across two intersecting lines is a rotation. You reflect it. All you did is you rotated it. I'm sorry. You reflect. You rotate it. Okay. Crazy stuff, right? Crazy. You don't believe me? Let's try it. So we have the letter R. This is a pirate's favorite slide. Okay, that's overused. I'm sorry. Anyway, we're going to reflect R across line L and then across line M, and we're going to see what happened and think about what's the distance that we're going to do. Okay. I'm going to take this point right here. What I'm going to do is need to make a line that's perpendicular to that one. Okay. I'd say that's about perpendicular. I'm actually going to take... Oh, Miss Twilly, you missed. That's pretty close. Okay. Because I need to kind of get the ball rolling. When I reflect it, I need to take this distance and I redo that distance over here, right? That's going to be the back end of my R. I need to take this distance. I need to redo it over here. So that's going to be the front. So my R it's going to be backwards now. And there we go. That's my R. Again, because this distance has to be the same as this distance, reflection. This distance, same as that distance. Now I need to do it again. Now I take my back point, and it's about 2 jumps. I know, guys, you're gonna be like, Mr. Wilder, this is very scientific. I know. Don't tell Miss right. Okay, so now this one we need to make 2 jumps like that. 2 jumps like that. It's pretty close, not too bad. So here's what I want you to notice. Oops. My orientation is the same, and now I've moved. I've translated. Okay. Now let's get out. Let's get a ruler. I want or show you something neat. Let's take this distance right here, right? The distance between those two. Let's see how far apart these two R's are. So there's one of them, right? And there's 2. Oops. For human error. If you look, the distance between your 2 R's, this is 2 times the distance between L and M. Okay? So that was pretty neat. It worked. Kinda. Well done. Well done. Give herself a hand. Okay. So there we go. If you reflect it across two parallel lines, it's a translation that's twice the distance of the distance between the two parallel lines. I know I said distance a lot, guys. I'm sorry. Let's try another one. We're going to take this R, we're going to reflect it over A and then over B. We're going to see what actually happened and kind of pay attention to what the angle of rotation is. Okay. Alright, we got to reflect this R across A first and then against B. So I'm going to start by taking this point, making a good old perpendicular. It's pretty close. I like to use this point back here, right? Making a good old perpendicular. So now I take this distance, okay, and then I'm going to go that far over here. And then I'm going to take this distance, go this far over here. So let's see, I'm going to need to go, oh, I need to take that one too. Let's take another one for fun. One, two, 1, 2. Okay, so that's the back, top, so it's going to look something like that. That's going to be my R. Okay, then we'll reflect it across B. Oh, I don't need to make it that long. Okay, it's about here. This guy ends up about over here. And this guy ends up about over here. Okay, so that's the front of my R. Here's the back. Oopsie doodle. Mr. Twilliger, what are you doing? Okay, so that was back, bottom, there we go, and there's my R. Now I have a rotation around. Okay, so if I do this, what angle does that look like to you guys? That's right, that's a 90-degree angle. So when you reflect against two intersecting lines, you get 2 times the measure of the angle between A and B. Okay? Let's talk about something else. In a plane, any 2 congruent figures can be mapped on each other by a composition of at most 3. So that means you should be able to use 3 or less. We only got one more to talk about, and that's a glide reflection. What that is, ready? I'm going to give you my own 2 cents. It's a composition of a translation and a reflection. I have an animation I'm going to show you guys about this one actually. Right here. Let's take a look at this. These are glide reflections, guys. You reflect it, then you slide it. So that would be one glide reflection. Then you reflect it, you glide it. That'd be another one. You reflect it, and then you translate it. You reflect it. Now a lot of people ask, can you translate it first, then reflect it? Yeah, that's fine. They both work. Okay? So let's try one. I have to redraw this triangle. Let's draw a text first. Good old text. You know they say things are bearing Texas, but this is a small triangle. -1, 3. E. -2, 1. X. negative 5, 2. T. Okay, so we're going to reflect across x equals 0, also known as the y-axis. Okay, because where's x always 0? Well, right here. Let's try that again. Where's x always 0? Well, right here. Okay, and then we're going to slide it, translate it, y minus 5. Pretty much slide it down 5. Okay. Well, let's actually connect these dots. We're real life people here. Okay. First thing let's do, let's reflect it. So E is 1 away from the y-axis, so E prime is right here. Right? Let's use green. T is 1, 2, 3, 4, 5. So we go 1, 2, 3, 5. That's my T prime. E prime. And X is 1, 2. So we go 1, 2 over. Make sure it's perpendicular. That's my X prime. Connect these bad boys. And I have my reflection. Now I have to translate down 5 because of this guy right here. So it's minus 5. Going down 5. Okay? It's red. So E needs to go down 1, 2, 3, 4, 5. This can be my E double prime. Also my ending point. That's where this is going to be my image. Where text is my preimage, this will be my image, your resultant. X needs to go down 1, 2, 3, 4, 5. That's X double prime. And T goes down 1, 2, 3, 4, 5. That's my T double prime. Connect the dots. And there we go. We reflected it. We glided it. We have our new points. E is at what? 1, negative 2. T double prime is at 5, negative 3. And X double prime is at 2, negative 4. Okay, not too bad. Good. What's this last slide? Oh yeah. Okay, some things to keep in mind. There's only 4 isometries. Translation, rotation, reflection, glide, reflection. Translations and rotations are the only ones that keep the same orientation. That means if you're looking at the letter R, it's not backwards. Okay? Reflections and glide reflections, now when you look at the letter R, it's backwards. If you don't believe me, look at your computer screen upside down for the glide reflection. And it's backwards. Okay? So anyone's with reflection is backwards, just like when you look into a mirror. Okay? All you guys write it. And last one, each figure is an isometry. What type of isometry maps the original P to these P's? Well, for A, if you look at that sideways, is that incorrect orientation? Why, yes, it is. It's still a P. It's not a Q. So that means it is a... But it's not still straight up and down, so I know it's a rotation. Okay. Well, this P. Well, this P just moved from up here to over here. It's a translation. Well, this P. If I look at it upside down, it's not a P at all. It's actually Q. And it was slid. So that's a glide reflection. Okay. That's it, guys. And chapter 9. Enjoy.